Let's have a look at this exam question that combines momentum with energy principles and work. It says a 4 kilogram wooden triangle is at rest on a horizontal, frictionless surface. A ball of mass 0.1 kilograms thrown horizontally at 10 meters per second collides elastically with the wooden triangle. As a result of the collision, the ball rebounds vertically upwards as is shown below. Ignore air friction. The first question here says that we have to state the law or principle of conservation of linear momentum in words. Remember here some key important words to include. The total linear momentum of a closed or isolated system remains constant or is conserved. Note that if the words isolated and total are missing from your principle, you will not get full marks for your answer. The next question says, explain when a collision is said to be elastic. An elastic collision will happen when both your linear momentum as well as your total kinetic energy is conserved. So linear momentum is conserved, kinetic energy conserved. Then we can say that a collision is elastic. This is very important because we are going to use these principles in answering questions a little bit later. Question 5.3, calculate the speed of the wooden triangle immediately after the collision. So before the collision, we can see here that the initial velocity is going to be 0 meters per second for the block. And if we look at our little ball here, it has initial velocity of 10 meters per second. So because this ball is traveling to the right, I'm going to make to the right positive. Then we also know the mass of this ball 0.1 kilograms and the mass of the triangle 4 kilograms. So here what we have to do initially is we have to give a formula. I'm going to use the sum of the momentum before is going to equal the sum of the momentum after. Remember, momentum equals mass times velocity, so it's going to be the mass of the ball times the initial velocity of the ball plus the mass of the triangle times the initial velocity of the triangle is going to be equal to the mass of the ball times the final velocity plus the mass of the wooden triangle times its final velocity. Now we can start to substitute our values. Firstly, the mass here 0.1 times the initial velocity plus 10 plus the mass of the block 4 times initial velocity of 0. 4 times 0 gives us 0. Then the mass of the ball 0.1 times my final velocity. Now, since we're talking here about linear momentum, remember that this is movement in one direction. We are going to say that since the ball is moving vertically upwards here, it actually has a 0 velocity in the horizontal plane. Therefore, the final velocity in this plane is 0 meters per second. And here we're going to plus this with the 4 kilograms and then our unknown, the final velocity. If you go and solve this, the velocity of the object or the wooden triangle is going to be plus 0.25 meters per second. Because it's plus, it's to the right. Remember that velocity is a vector, therefore we need direction. Then when we look at our next question, use only energy considerations to calculate the maximum height reached by the ball after colliding elastically with the wooden triangle. So when we can only use energy considerations, here I'm going to look at kinetic energy, and I'm also going to look at the conservation of mechanical energy. We're going to use energy considerations here to calculate the maximum height. And remember that this is now by the ball after colliding elastically with the wooden triangle. So the first energy principle that I'm going to use here is the change in kinetic energy. The total change in kinetic energy remains conserved in an isolated system. So we can say the sum of the kinetic energy initially is equal to the sum of the kinetic energy final. And remember now this is going to be a half mv squared. So if we go and just quickly elaborate on this, half m, half the object being the ball, times the initial velocity of the ball squared, plus half mass of the triangle times the initial velocity of the block squared, but the block is not moving initially, so this is going to be plus 0. This is going to be equal to a half the mass of the ball times the final velocity squared, which is our unknown, plus a half mass of the triangle, velocity of the triangle squared. Now we can go and substitute our values into this formula. It's going to be for the first part over here, a half times 0,1 times the initial velocity of 10 squared plus 0 is equal to a half times 0,1 times Vf squared, our unknown, plus a half times 4 times the velocity which we have calculated up here, 0,25 squared. When we go and solve this, we can go and calculate the final velocity here, and this is going to be the final velocity of the ball, which is 9,87 meters per second. Remember, this is vertically upwards. This is why I'm not using linear momentum as well. Remember, linear momentum only in one direction. Vertically, the velocity was 0 in our previous question. When we use the principle of conservation of kinetic energy, we can calculate the velocity of the ball as 9,87 meters per second, and it will be upward. We can go and calculate the height by using the principle of conservation of mechanical energy. So here we can say that EM initial, mechanical energy initial, equals EM final. This is basically the same as saying that the kinetic energy initially plus the potential energy initially is equal to the final kinetic energy plus the final potential energy. We can now go and elaborate on this. It's going to give us a half mvi squared plus a mgh initial equals a half mv final squared plus mgh final. Now remember, h final is our unknown here. So let's quickly go and substitute values into this formula. I'm just going to move over to this side. We're basically going to say that this is going to be a half times the mass of 0,1 times 9,87, what we've just calculated over here, 9,87 squared, plus our potential energy initially is 0, is going to be equal to the kinetic energy final, which is 0, plus mgh final, m 0,1, g 9,8 because it's acceleration, and then hf is our only unknown in this equation. When we go and calculate hf, it will give us a value of 4,97 meters. So what we've done here is using our energy considerations. We first went and calculated the final velocity of the ball as it goes upwards vertically, 9,87 meters per second, and then we used the principle of conservation of mechanical energy, Ek initial plus Ep initial equals Ek final plus Ep final, to calculate the height of 4,97 meters. The last question here. After the collision, the wooden triangle continues to move on the horizontal frictionless surface and then strikes a rough surface, which means now we will have friction. It experiences a frictional force of 4,8 Newton, so this is our frictional force when sliding across the rough surface until it comes to rest, which means our final velocity here is going to be equal to 0. It says use only energy principles to calculate the distance covered by the wooden triangle on the rough surface. So what we are going to try and calculate here will be our distance covered, so change in x. There are different ways in which you can do this. I'm going to use the Work-Energy Theorem. The net amount of work done is equal to the change in the kinetic energy. And here we know that the only thing that's going to make this object stop is the force of friction, and therefore the force of friction is our F net force. So I'm going to elaborate on work net, and this is going to be the force of friction multiplied by the change in x. Cos theta is going to be equal to Ek final minus Ek initial. We already know that the frictional force is 4,8 Newton, change in x is our unknown, and we know that the frictional force is in the opposite direction to the displacement, 180 degrees. This is going to be equal to a half times the mass of 4 times 0 squared, because we said that our final velocity here is 0. Anything times 0 will give me 0, minus Ek initial, which will be a half times 4 times our 0,25, which we calculated in question 5.3 squared. Remember the square, very important. And if you then go and solve this, the change in x is going to give you 0,03 meters.